Hey everyone, and welcome. Today, we're going to pull back the curtain on one of the most important but kind of invisible technologies in software development today, the language server protocol. You could say it's the secret sauce that makes your code editor feel less like a simple text file and more like an intelligent partner who's got your back.
You know that feeling, right? You start typing, and it just knows what you're trying to do. It's flagging your typos before you even think about hitting compile, it finds definitions in a flash, and the autocomplete is almost spooky accurate sometimes. Well, here's the thing. It's not magic. It's actually a really elegant solution to what used to be a very, very messy problem. So let's dive in.
To really get why the language server protocol, or LSP for short, is such a huge deal, we have to go back in time, to the world before it existed. And honestly, it was a bit of a nightmare for tool developers.
At the heart of it was this problem, what we call the M by N complexity nightmare. So just imagine you've got M different programming languages, Python, Rust, Go, TypeScript, the whole gang. And then you've got N different code editors, VS Code, Vim, Emacs, Eclipse. To get all those nice, smart features for every language in every editor, you had to write a totally unique, custom implementation for each pair. That's M times N different integrations to build and maintain. It was not scalable at all.
And this quote just hits the nail on the head. Think about it. If you built great C++ support for Eclipse, which is written in Java, all that logic was, well, in Java. Now say you wanted that same support in VS Code, which is built on Node.js. Too bad. You had to start from scratch. You had to rewrite the entire complex parser and type checker all over again. The amount of duplicated work across the industry was just massive.
Okay, so things were a mess. But out of all that chaos, this really simple but powerful idea started to emerge. You can think of it like a universal translator for code intelligence, and it was about to change everything.
The core concept of LSP is just beautifully simple. Instead of cramming all that complex logic for understanding, say, Python directly into an editor plugin, what if you just pulled it out? What if you put all the language smarts into a separate, standalone program, a language server? The editor just has to worry about the UI, and the server worries about the language. All they need is a common way to talk to each other.
And this right here, this is the aha moment. This is what changes the whole game. The problem goes from that M times N multiplicative nightmare to a simple additive M plus N model. Now, if you're creating a new language, you only need to write one language server, and boom, it works in any editor that speaks LSP. And if you're building an editor, you just implement the LSP client once, and you get support for a ton of languages right out of the box. It's just a way smarter way to work.
Now, this idea didn't just appear out of thin air. Projects like OmniSharp for C# and the TypeScript server had already kind of proven that this client-server model could really work. But the huge moment came in 2016, when Microsoft, Red Hat, and CodeVial all teamed up. And what's so important about that collaboration is that they made sure LSP wouldn't be some proprietary Microsoft thing, but a true open standard for the entire community.
Okay, so we've covered the why, but how does the magic actually happen? How do the editor and this language server actually talk to each other under the hood?
Well, the whole thing is built on a protocol called JSON-RPC 2.0. The easiest way to think about it is just a very simple, lightweight set of rules for sending messages back and forth. And these messages are just plain text using JSON, which pretty much every programming language on the planet can understand. This is that universal language that lets, say, an editor written in Rust talk to a language server written in Go, and neither of them has to care about what the other one is built with.
And the whole conversation follows this really clear three-step dance. First, they initialize. It's like a handshake where they introduce themselves and agree on what features they each support. Then comes the most important part. They synchronize. As soon as you open a file, the editor tells the server about it, and from that on, it sends over every single change as you type. This is crucial because it means the server always has a perfect, up-to-the-millisecond copy of your code in its memory. And finally, when you close the editor, there's a clean shutdown so everything can exit gracefully.
And this connects directly to the things you do every single day. So when you hover your mouse over a function to see its documentation, your editor is actually firing off a text document/hover request to the server. When you right-click and hit Go to Definition, yep, that's a text document/definition request. The protocol basically just maps all these common editor features to standardized messages that every server knows how to answer.
So look, a great idea and solid tech are one thing, but the real story of LSP, the amazing part, is the incredible ripple effect it had on the entire world of software development.
Creating this single open standard led to what you can only really describe as a Cambrian explosion of development tools. All of a sudden, if you were working on any language, no matter how niche, you could build one server and instantly get top-tier, world-class editor support everywhere. It just blew the doors wide open for innovation.
And just look at the sheer breadth of support today. I mean, of course you've got the big ones. Rust has Rust Analyzer, Go has Go+, C++ has Clang D. But the real proof of LSP's success is when you see servers for languages like Zig, or even COBOL. I mean, COBOL, if that doesn't tell you just how universal and impactful this solution has become, I don't know what will.
And on the other side of that M plus N equation, the editor adoption has been just as huge. We're talking everything from mainstream editors like VS Code and NeoVim to heavyweight IDEs like Eclipse and IntelliJ and even web-based tools like JupyterLab. They all speak LSP now, creating this one big unified ecosystem.
And the ecosystem isn't just growing, it's getting faster. Check this out. A project ported the TypeScript language server from Node.js to a native binary. On a really big codebase, they saw a staggering 13.5 times speed up in how long it took to check the code. That's not a small tweak, that is a massive leap in performance, and it's possible because of this decoupled architecture.
So we've seen where LSP came from and everything it's accomplished. But this story is far from over. In fact, LSP is now becoming the critical foundation for the next generation of our development tools.
One of these evolutions is something called LSIF. So LSP is perfect for when you're actively coding, right? It's a live conversation. But that's not really practical for a website like GitHub where you're just browsing code. LSIF, or the language server index format, lets a server basically dump all of its knowledge into a static file. You can then upload that file, and it powers features like go to definition right there on the web, with no live server needed.
And this is where it gets really exciting, especially with everything happening in AI. You know, AI coding assistants are amazing at generating text. But let's be honest, they can sometimes just make stuff up. LSP is becoming the crucial link to reality for them. The AI can use LSP to ask the language server, hey, does this function actually exist in the codebase? Or what are the real parameters for this method? It gives the AI verifiable facts to ground its suggestions in reality.
And listen, this isn't some far-off theoretical idea. It is happening right now. The upcoming version of the protocol, LSP 3.0, is actually adding standardized support for AI-powered inline completions. You know, that ghost text you see from tools like GitHub Copilot. The protocol itself is evolving to treat AI as a first-class citizen. So when you take a step back, it's pretty clear. The language server protocol started as this really clever fix for a frustrating engineering problem. But it did so much more. It untangled our tools, it unleashed this wave of innovation, and it basically gave our editors a brain. So the question we're left with now is, as it becomes the factual backbone for artificial intelligence, what new powers is it going to unlock next?